Parallax method. Have you ever looked at something with one eye closed and then the other? Noticed it seems to move? That's parallax. And believe it or not, this simple concept helps us measure the distance to planets and stars. Try this. Hold your finger out in front of you and close one eye. Now switch eyes. See how your finger seems to jump? That's the parallax effect. What is parallax? Here you have a scale. Just above there is a pencil. You are looking at the pencil from point A and see the value is 2. Now you are looking at the tip of the pencil from B. Now the value is 1. From C the value is 3. Parallax is the apparent shift in the position of an object when viewed from two different points. Why is it important? Here you have moons, planets, stars. We use parallax method to measure very large distances such as distance to the moon, planets or stars from Earth. Example. Close your left eye and look at an object with your right eye. What you see? You see the flower in blue background. Now close your right eye and open your left eye. Now what you see? You see the rose in the green background. You will see the object seems to shift slightly. That shift is parallax. Important terms. Basis B. The distance between the two observation points. B. Angle of parallax theta. The angle formed at the object by the two lines of sight is angle of parallax theta. Distance to the object x. It can be calculated using the formula theta equals b upon x. So x equals b upon theta. Final formula x equals b upon the basis upon the angle theta. B, the baseline, distance between eyes or observation points. Theta, parallax angle. X, distance to the object for small angles in radians. Astronomy application. For stars and planets, the parallax angle theta is very small. So we need a large baseline, like 2 points far apart on Earth or Earth's position in orbit in two different times. Here in the picture, we have kept the baseline as the diameter of the Earth, or it can be two different positions of the Earth in the orbit in two different times. Distance of the moon from Earth. Have you ever wondered how scientists measure the distance to the moon without ever going there? Let's learn a simple method that uses nothing but angles and maths, called the parallax method. Look at the picture. Here's how it works. Imagine two people standing on opposite side of the earth, one at point A and another at point B. They both observe the moon at the same time using telescope. They notice the moon appears in slightly different position against distant stars. From A, the moon appears on the right of the distant star. From B, the same moon appears to the left from the same star. Concept. We can measure the distance to the moon by using the concept of parallax. When the moon is observed from two diametrically opposite points on Earth, it appears at slightly different position against the background of distant stars. Now, the star has gone to infinite distance. The line of sight of the star becomes parallel. Observation setup. Let A and B, two opposite points on the Earth's surface. C is the center of the Earth. M is the moon. From A and B, the moon is observed using telescopes. The apparent shift in the position is measured as angles θ1 and θ2. The total parallax angle AMB is θ1 plus θ2 equals theta. So the parallax angle is impossible to measure from the moon. So we use a different technique, the parallax techniques, to measure the parallax angle. Important assumptions. AM equals or approximately equals to MC. The C point has been missing here. Let me write that. The distance from point A to the moon is approximately equal to the distance from the Earth center to the moon. AB is the diameter of the Earth, which is a known value. Formula: theta equals the baseline AB divided by MC. MC equals AB upon theta. Final formula: if AB Earth's diameter and theta the parallax angle in radian are known, the distance to the moon MC can be found using the formula MC equals AB upon theta, the diameter of the Earth divided by the parallax angle. Note: parallax angles are measured using astronomical telescopes. For more accurate results, theta should be in radians and as small as possible for better precision. AB is a known value, about 12,742 km, and theta is measured with a telescope. With this, we can estimate the moon's distance from the Earth, roughly 3,84,000 km.